Hello everyone, this is Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to Maths University, Rohtak. So today our next topic is change of variable and area, right? So in our previous session I told you about change of order of integration, but here I am talking about change of variable. That means our variable, if suppose variable is given dx dy or x and y, so our variable will be changed into a new variable u and v, and integrand will be changed into du and dv. So to change a new old variable into a new variable, there is a process here. So just begin our process. So okay, okay, so this is your change of on variable, right? So here we can see that let the double integral as be double integration fxy dx dy. So this is your old variable x and y. It is so changed by the new variables u and v. The relation of x and y with u and v are given by as x is a function of u and v, y is a another function of u and v also. That means you give in your question u and v will be given, and you will find your new variable by using the old ones, right? And after the changement of the variables, your integral will be integration. All integration is double integration fxy dxy will be changed into a new variable r dash is your another reason phi uv and psi uy uv, and there is a Jacobian here, and this is your modulus of Jacobian du dv. That means your dx dy value is Jacobian into du and dv. To calculate Jacobian, so your Jacobian is del xy upon del uv. That means this is a modulus value, that means determinant value of x, the derivative with respect to u, x derivative with respect to y, and y derivative with respect to x, u, and y derivative with respect to v. So this is your Jacobian value, right? And these are your partial derivatives. So just remember your Jacobian value, that this is your always mod value. That means always absolute positive value. If it is negative, so mod value always gives positive, so it will be positive. So there is a question here: evaluate double integration x plus y whole square dx dy, where r is the parallelogram in the xy plane. So this is your given variables with vertices 1 0 3 1 2 2 0 1. These are the vertices of your parallelogram. Using the transformation u is equal to x plus y, v is equal to x minus y. So this is your new variable, and new variable is changing as by the transformation u is equal to x plus y and v is equal to x minus 2y, right? So sorry, the reason of integration is a parallelogram. ABCD, we are considering the vertices of this region as ABCD, where A is your first point 1 0, B is your 3 1, second point, C 2 2, D 0 1, right? And this will also in your XY plane, because all of the points are positive, so it will lie in your positive quadrant or first quadrant, right? Now, transformation is given here, u is equal to x plus y and v is equal to x minus 2y. So the new region of integration is a rectangle a dash b dash c dash d dash in the uv plane. Our xy plane will be changed into a new plane u and v, right? Now, how do we know that this is a rectangle? So just transform the old ones into a new ones. So at point at vertices 1 0, so find 1 0, you know, where new variable. So u is equal to x plus y. So just write here u is equal to x1. X is 1 here, y is 0. So 1 plus 0, u is equal to 1. V is equal to x minus 2y. So v at 1 0, your v is equal to 1. That means we are having a new vertices a dash 1 1, right? And now at the point 3 and 1, this is your second vertices. So just to find at point b3 1, so your new variable u is equal to 4 and your v is equal to 1. So we are getting new vertices b dash is equal to 4 1 at point c. So you are getting a new vertices c dash is equal to 4 minus 2 at point d 0 1. So your new vertex is d dash is equal to 1 minus 2, right? Now draw a rough sketch figure here. So this is your parallelogram. So we can see that a b c d is your parallelogram in the xy plane. Now draw a dash b dash c dash d dash point. So in your new plane uv, so this is your u axis, this is your v axis, right? Now 1 1 lie on x in the positive quadrant. So in the first quadrant, so this is your point 1 1, this is your a dash vertices, this is your b dash vertices 4 1, right? This is your c dash vertices 1 minus 2, this is your d dash vertex d dash, sorry, this is your 4 minus 2 c and 1 minus 2 d dash, right? So we can see that a dash b dash c dash d dash, this is your rectangle. We can see that we are getting our point vertices point and this is your rectangle. Now to find, we have converted xy variable into a new variable uv, but we have our xy value, but we don't have our dxdy value. To calculate dxdy, so we need the value of x and the value of y here. So just calculate the value of x and y. So u is given x plus y, v is given x minus 2y. So just subtract both of the equation. So u minus v is equal to x will be cancelled out, 3y is here. So y is equal to u minus v upon 3, and just put the value of y in your equation 1. So u is equal to x plus y value. So x is equal to 2u plus v upon 3, right? So we have x is equal to 2u plus v upon 3 and y is equal to u minus v upon 3. So in each and every question, after finding the points, we will find the value of x and y by the using the transformation. That means solve both of the equation, then calculate x and y, right? Now for the Jacobian, we need del x upon del u derivative, del x upon del v, del y upon del u, del y upon del v. So del x upon del u, that means x is differentiating partially with respect to u. So it will be 2 by 3 here. V upon 3 variable will be 0 because it will become constant. We will consider it as a constant. So 2 by 3 del x upon del v, that means 2u upon 3 will be 0 and v upon 3 differentiation will be 1 by 3. Del y upon del u, so del y upon del u means the u by 3 is differentiating with respect to u, so it will be 1 by 3 minus v upon 3, that means minus 1 by 3, right? So just to find a determinant, so 2 by 3 into minus 1 by 3, it will be minus 2 upon 9, and minus 1 by 3 into 1 by 3, 1 minus 9. So it will be minus 3 upon 9, that means minus 1 by 3. So it is we are getting a negative value here. So just take modulus value. So it will give positive value. So dx dy is equal to modulus Jacobian du dv. So 1 by 3 du dv. Now, so we can convert new variable as after converting the old ones into new ones. So we are getting double integration x plus y whole square value. So we need to calculate x plus y. So you can see that x plus y is equal to x value is 2u plus v upon 3, 2u plus v upon 3, and y value is u minus v upon 3. So u minus v upon 3, v will be cancelled out. 2u plus u, 3u upon 3. So x plus y value is u here, right? Now, so u is square, that means x plus y whole square. So u is square upon 3 du dv. Now we need to find the limit of u, right? And limit of v. So just see your figure. Okay, this one, du dv. So this is your, we can see that the value of u is here 1, and u and the value of u is here 4. That means our lower boundary is 1 and our upper boundary is 4. So uv, uv and uv. So value of u is 1, and lower bound and upper bound is 4. So our limit of u is 1 to 4. Now check the limit of v. So v is moving -2 to 1, -2 to 1. That means our lower bound of v is -2 and upper bound is 1, and the lower bound of u is 1 and upper bound of u is 4. And just integrate first one with respect to u. So 4 cube minus 1 cube upon 9, and after the integration of u, just integrate with respect to v, right? So this is your integration of. Now your answer is 21. We are getting our answer as 21, right? This exercise is related to your change of variable. There is another example here. So you will see this example and try to understand this example. The above example and this example, both are methods are same. Value will be changed, but both method are same. Just apply the same method here. This is your gamma function, right? Here this is your gamma function. So you can use directly gamma function, or you can convert it into your polar form, then apply the rule here, right? So no need to, you can write u is equal to sin square theta and 1 minus sin square theta cos square theta. So just cos theta will be outside, then you can apply your gamma function here, right? As I told in our multiple unit first lecture, right, in our previous lecture, I think. So you can write u is equal to 1 minus sin square theta. Here you can put also v is equal to 1 minus sin square theta, right? You and just solve it. You can apply gamma rule here, right? This exercise is related to your change of variable. So just do your exercise. Now, our next topic is area in Cartesian coordinates. So to find the area, just draw your figure and just find the limit and just write your in formula. So find the area between the parabola y square is equal to 4ax and x square is equal to 4ay. That means limits are not given here. So first you have to find your limits, right? So y square is equal to 4ax and x square is equal to 4ai. These both are the parabolas, but one parabola is parallel to x-axis and one parabola is parallel to y-axis. Now to check which one is parallel to y-axis, if x square is equal to 4ay is given, that means this parabola will parallel to x-axis. So this parabola is parallel to x-axis. This is your x square is equal to 4ay parabola, right? You can see in your figure that this is your x square is equal to 4ay, and another one is y square is equal to 4ax. So this parabola is parallel to x-axis. So this is your parabola parallel to x-axis. That means y square is equal to 4ax. Now both of the parabola will intersect at a point. So just find your intersecting point. So for the intersecting point, what will you do? Just do put the value of x from here and into here, another one parabola. So x square is equal to 4ay. So just write the value of x here. So you are getting y is equal to 4a. That means 4a is your intersecting point here, right? Now, your area is double integration dx dy or double integration dy dx, right? If the function is not given there, that means your area will be dy dx or double integration of dx dy. So you can draw a strip parallel to x-axis or you can draw a strip parallel to y-axis. Both will be correct. So we are here draw a strip parallel to x-axis to cover the whole region. So you can see that this is your bounded region, right? Now, if this strip is parallel to x-axis, so that means this strip is touching the line OA, curve OA, and OA curve is your y square is equal to 4ax. So parallel to x-axis, that means we will find the value of x from here. So your x value will be y square upon 4a. That means our lower limit is y square upon 4a. Now it touch the parabola at x square is equal to 4ay. That means your value of x from here, it will be 2 root ay, right? So our upper limit is 2 root ay. Now x is equal to y square upon 4 is your lower limit, x is equal to square root of 4ay is your upper limit, and dx dy, value of y. So y is moving vertically. So the value of y in our bounded region, here 0 0 and here highest 4a. So our limit of y will be 0 to 4a. Now just integrating with respect to x, so square root of 4ay minus y square upon 4a, upper limit is this one minus lower limit. Now just different integrate with respect to x, right? So integrating with respect to x, y, so you can see that root y integration will be this one and y square will be this one. Just apply the limit, upper limit minus lower limit, and after the solution you can get your answer. See that 16a square upon 3, right? So this is your area, that means dy dx or dx dy. So if limits are not given, so first you will sketch your reason and find, draw a strip parallel to y-axis or parallel to x-axis, and just find the limits of integration. There is an exercise related to your uh, double integration in Cartesian form. So find, use double integration in the following question to find the area of the curve, right? So just do yourself exercise, and is, if you have any doubt, then you can ask me. This is your exercise, right? So just do your exercise. In our previous session, I will discuss the topic uh, area in your polar coordinates, right? This is your xy is your Cartesian coordinate, and r theta form is your polar coordinate. So I will discuss this topic in our next session, right? Thank you.